Hi everyone, I'm Dustin Van Stee, a data scientist with the IBM Garage for Systems, and in this video I'll be giving you a tutorial on how you can set up deep learning frameworks for IBM Power Systems. I will show you how to install the prerequisites required, and I'll show you how you can train a model using deep learning frameworks with relative ease. If you're familiar with IBM Power Systems, you might have heard of a line of accelerated servers that we call the AC922 or IC922. These servers are accelerated by NVIDIA GPUs. And to really take full advantage of these systems, you need to be constantly updating your software stacks. So in the past, you might have heard of software called Watson Machine Learning Community Edition, and we would use this software to help us install frameworks like PyTorch and TensorFlow easily. But now we're transitioning from that project into a new project called OpenCE. It's a GitHub-based project that will make it easier to control our build schedules and deploy software on our time frame. So with that, let's jump in and check it out. Okay, we are now ready to do the git clone and installation of OpenCE. So before we do that, I just wanted to browse to the OpenCE GitHub repository. Here you'll find a number of useful files and README instructions about how to set up your environment for installation. There are a number of different prerequisites. I do highly recommend you check out the README. In here it gives you an overview of the directory structure, how to get started, some CUDA requirements, and some other details. One important directory to probably keep paying attention to is the ENVS directory. This is where you have a common number of different environments defined already here so that you can quickly install something. Today I'm going to be installing PyTorch 1.6, which is defined in this PyTorch env.yaml file. If you had other requirements, these are the files here that you could either copy or you could modify them for your environment. So with that, let's do a git clone. I'm going to copy the URL, and I'll set up a demo directory. And here we go. And as you can see, we've got all the source code from the OpenCE project. The next thing that I've already done is I've created an Anaconda virtual environment to run my build. The command that you would use to do such a thing could look something like this. I'm not going to remove my Anaconda environment because I've already built it, but you would just do a conda create -name OpenCE build or whatever your choice of Anaconda virtual environment name is, and then the Python version. After you've built your Anaconda virtual environment, you're also going to want to install this package called conda build. It has a couple of dependencies that you'll need when you go through and do the installation. I've already done it here, but just making sure that you're aware of that. Next, we're going to install one other dependency. It's the TensorRT library from NVIDIA. It's also documented in the README file. I've already pre-downloaded it. Oh, I have to make a directory called local files. I've already downloaded this file to a different directory and I'm just copying it over here. Now I've got it available so that when I kick off the build, I've got that dependency available. Finally, we're going to get ready to do our build command. So I've got one prepared already. I'm going to cut and paste it over here and explain a few arguments. So we're going to be calling the OpenCE build env.py file. That's the workhorse script that will pull all of the different dependencies together. I'm going to be building a GPU-based set of applications here, and the library that I want to build is PyTorch. And I'm using this Docker build flag, which it will invoke Docker behind the scenes to build out my libraries. So let me give this a run. And I should mention that Docker is a very nice way to do this. If you do bare metal, you may have some issues with your environment potentially being different than the environment that the development team was using to build out this software. I've had good experience with Docker and highly recommend it. We're going to let this bake for a while. It does take around a half hour to 45 minutes to get everything up and running. When this is done, I'll return and we can keep going. Okay, and we're back. And now that the build is complete, I have a directory called conda build, and inside of conda build is my set of libraries. So now I'm at the point where I can create a different virtual environment that will actually contain the PyTorch 1.6. I could also install it here as a demonstration. I'm going to create just a new Python virtual environment and do the installation. Here I'm going to create OpenCE PyTorch 1.6 using Python 3.6. I had a virtual environment up and running before with that same name. I'm just going to overwrite that with this one. This will take a little bit of time. I'll be back in a moment. Okay, great. Now we've created a new kind of virtual environment. The next thing I'll do is I'm going to activate that. All right, so now I've got my virtual environment set up, but there's nothing inside of it yet. And this is where I'm going to install the packages that I just built for PyTorch. So I'm going to run this special command. Essentially, I'm doing an install using my channel of a local directory called conda build, which is underneath my OpenCE, and I'm going to install PyTorch. Let's see what happens. Okay, that's great. Now I've got PyTorch installed. Let me check. And what do you know? We've got PyTorch 1.6. So that's how you can install pretty much any kind of bleeding edge deep learning framework using the OpenCE repository. But if you recall from the beginning of this presentation, I said we were going to do something with FastAI version 2. Well, FastAI version 2 is the latest software from that team that makes deep learning relatively easy to do. And I think we should kind of do it today. So the one dependency that the FastAI team has is that you have the latest, greatest PyTorch, which is 1.6. So let's go through and install FastAI. I'm going to do this a little bit quickly. There are a number of different other packages that have to be installed here. I'm going to install FastAI with no dependencies because FastAI by default wants to bring along its own PyTorch, but I've already brought it. And then there's a number of other dependencies. I'm just going to speed through this here. Now we're installing Pandas. Let's install Spacey. Well, let's install scikit-learn. And we'll install a few other packages as well. Just drop these in here. Don't worry about all these packages. You'll discover them when you try to run FastAI if you're missing them. But at this point, we have installed all the different packages we need to run FastAI. Okay, so here is the FastAI repository. We're going to git clone the FastAI code. They've got some sample notebooks that we're going to make good use of during this tutorial. So here we are. And I've already taken the liberty of downloading those FastAI version 2 notebooks here. So I'm going to start up a Jupyter notebook. I have an alias to kick off a Jupyter notebook on a port that I've already pre-configured, such that when I come over here, I'm able to get that up and running. So I'm going to go to the FastAI version 2 repository. They've got some notebooks from their class, and why don't we load up their lesson 1 notebook. And so their lesson 1 notebook is all about image classification. And so this is not to belabor the point here of deep learning and how all of that works, but it's mainly to show you how we can install the latest, greatest code. We'll get through some of this here. I'm downloading just a number of their different data sets, and we'll show some of their data. And why don't we download their ResNet model? And let's start training. So there we go. After just 3 epochs of training, we're down to about 8% error on this particular example. And if we go over here, we can check out the results of the model. So as you can see here, the results of this particular classifier were pretty good. We were able to classify different breeds of dogs relatively well. You can see the high numbers on the diagonal, which is what you want. You want not too many numbers on the off diagonals, which are misclassifications. So there you go. You saw how we were able to do deep learning using some bleeding edge frameworks, PyTorch 1.6, FastAI version 2, doing it in relatively short order, just a couple half hour or so of my time and your time. And we were able to build this out and get a great result. So thanks for sticking around with me, and I hope you are able to give this a try on your power machine.